Welcome to the latest SledgeCast. This SledgeCast, we're going to go over the valid parentheses or matching friends or brackets kind of problem. This is the LeetCode page. We're not sponsored, I'm just using their software, their website, because they have a nice description. But given a string containing just the characters, opening parenthesis, closing parenthesis, braces, and brackets, determine if the input string is valid. An open bracket must be closed by the same type of bracket. Open brackets must be closed in the correct order. Note that an empty string can also be considered valid. So we've got all these example cases here. These are all valid ones, and they've got this here. Yeah. So I actually put together some of my own test cases, and we're going to have a little spin on this, which is that other characters are also allowed. So go into my coding area here. I've put some together, some test cases myself. So we got different inputs here. We've just got some input around a word. Got a little mix of braces here. I'm going to take this example here, actually. I don't know if it's a good example. So these are table-driven testing Go, and they're really convenient for this kind of thing where you're testing different inputs to a function. So I can just really easily let's just add another test case here, and then that'll be run through my tests. So I can just do go test. It's actually dot/dot. Yeah, it actually ran, huh? But yeah, so you can see we're failing our tests. Why we're failing our tests is actually just because our function always returns false. So now we got to try to figure out how do we answer this problem. I chose this particular problem because I did it in an interview. So it's something you'll find if you're interviewing nowadays for different programming jobs. This is actually an easier problem. This is considered a LeetCode easy, and it is actually pretty easy. And I know the answer because I did this problem relatively recently. So yeah, so I'm just gonna get started on it. Walk you through it. So let's say we're looking at one of these test cases. Let's say it's this one here. So this is a valid case. Example case. So we've got this. So I'm just doing Markdown, except I went to the wrong project. There we go. So we got an example here. What we're going to do is, one of the first things we're going to do is we're going to read through the string by character. So that's something I didn't think of earlier, but I am going to have to figure out how to do that. So basically what we want is to read through our string, check each character to see whether it's one of those brackets, and then continue on. So we're going to need to iterate character by character through a string in Go. So Google, let's go to google.com, iterate through string character. There we go. So hopefully we don't have to go by rune because that's kind of a pain. I don't want to do it by runes though. Maybe I do want runes. I think I may actually want runes. So basically, strings in Go are Unicode, or Unicode 8. So I'm just doing the range of it. For position, character, it's the range. Yeah, character is just a variable. So I can just do the range of the word. So we go in here. I can do for character equals range. So this is my main function. I don't actually need this in this Go program, but I I mostly been doing this kind of structure for my Go program, so I put it in there anyway. So this would be range input, and I can do like this. And then we can do fmt.println character. Then I'm going to need fmt. There we go. So this should run now. What I can do here is I can do matched of this program is pretty simple. Go run main.go. So I'm missing return because they're supposed to return here. Alright, so this is basically printing integers. So why is it printing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Well, when you do range, it actually gives you index and then the value. It does this for maps, it does it for all sorts of things. So this is actually underscore comma character. It could also be like I. So if you're doing like a for I equals 0, I is less than length, I plus plus kind of loop, this is the index here. But I don't actually need it right now, so it's just going to be an underscore. And the underscore in Go just drops that value, so the program will ignore it. Alright. So now if we run this again, we should get characters. No, now we're getting values. So I guess it's giving me the rune value of this. So I wonder what happens if I do a string of this rune. I don't actually care about the rune values. So maybe I was a little bit too eager when I closed that Stack Overflow problem. What's this guy got? And I don't care about the characters, I just want the string. Yeah, so my problem is we're printing as ints. So he's got module C instead of module V to get the string. So if I do mod C, so we got 50 dash, what is it, printf now? He's using printf still. I'm using no ln, so we'll use printf. So this is print and format. So it's a little bit different than println. Println is a little bit simpler. So the input to this is basically some kind of string, some kind of formatting character like this modulo C, and then we're going to have some value here, which is the character. And then I'm also going to put a new line right after it. Like so. So now, let's run this. Alright, so now we have the actual characters. So I think what I can do is if I do sprintf, I will actually return a string char equals this, and then I should do println character, and hopefully this does the same thing. Probably because I still need the P. Alright, so now we've got that. We do not need this extra new line. There we go, so main writing for all the characters. Why is it actually require this much work? I don't know. Most languages will let you just iterate for the actual characters in a much easier way. I wonder if there's a golang caret. Because this is another way we could do it. We could have done it. So this guy's doing runes. One to two. So these guys are pulling ranges out of strings. They're doing interesting stuff. Anyway, I have one answer, so I'm just going to continue with this. Alright, so we have the character now. It's just ABC or normal characters. So now we're going character by character. We want to check to see if we got one of our opening brackets. So we're going to do an if character equals opening paren. Then we're going to handle it. I think technically we're string right now, so I'm going to switch to a string. There we go. And we're basically going to want to have a whole bunch of these, because we have 6 different cases we can handle. 1, 2, 3, 4, 5, 6. So we got opening paren, closing paren, opening bracket. Actually, let's change this. So basically, these are going to work pretty similarly. Here we go. So I'm going to have the opening ones, and then I'm going to have the closing ones. Alright. Flip this one. Alright, so we've got 6 cases here. We're opening a paren, opening a bracket, opening a brace. I'm not actually sure which one of these is a brace and which is a bracket. People seem to switch the names around a lot. But everyone calls this one a parenthesis. Alright. So these are our different cases. If we get like a normal character, like A or B or C, we're just going to ignore that. So we can also do, honestly, we can do an if else, or we can just do nothing. And I think it'll act the same way. So I'm going to leave it like this. So let's go back to our problem statement. So as we're going through, we see, okay, first character, opening parenthesis. Next character, closing parenthesis. So we can kind of cancel this from out. And the same thing here and here. So there's a couple ways to do this. One of the ways that I usually reach for first is to use a stack. So in our problem here, we don't actually care that much about the order. So you can have a bracket and then have some braces and then have another bracket and then have a parenthesis. So it's really just the parens are independent, the brackets are independent, the braces are independent. One way you can do this is with stacks. So basically, we would have a kind of like a vertical stack for. So this could be like the paren stack, parens. So whenever you get a paren, you kind of like put it in your stack. So that would be like this. And yeah. There we go. And admittedly, it would be at the bottom of the stack. Now, normally, I would draw this on a whiteboard, which is a little bit different from my laptop's ASCII symbology here. Basically, what I usually reach for first is just have a stack. So if you have 3 different things you're keeping track of, then you want to have roughly 3 stacks. So you end up with a stack for parens, you end up with a stack for brackets, and a stack for braces. And then I would have one more here. So and then basically what you do with this is if you hit a paren, you add that paren to your stack for parens. If you hit a brace here, alright, we add that to our stack for braces. We go here. And these backticks are just part of Markdown. They make it read a little bit fancier. And it also makes it easier to tell what different things are. So this is a bracket one. So these, you'll notice, are just the opening ones. So then finally we get this opening brace. So we're going to be putting that in. Cool. Close this. Some more spaces here. Alright, so we've gone about halfway through the string. We're here now. We only have these three left, which are these ones. So we go to the first one. It's a brace. We say, do we have any braces in our stack? The answer is yes. So we can then take this one out. Boom. That guy's gone. We go to our next character. It's closing bracket. We can take that out of our stack. Boom. And then the last character is, of course, this closing parenthesis, so we can close that, and then we're done. We've matched them all. All of our stacks are empty, and we know that this one is balanced. So what happens if maybe there's another character at the end here? So what if this was like X, closing parent? So then we'd have another X closing paren to search through. We'd say, okay, X we can ignore because that's not one of our special characters. Closing paren, we can say, oh, wait a second. There's a closing paren. Are there any parens in our paren stack? The answer is no, which tells us that we're imbalanced. So we could also exit here. Another case that could happen is if we had X, or let's say we had ABC, and then we had an opening brace. So we go through ABC, we don't care about any of these characters, we have an opening brace. That opening brace would go into our stack, and then we hit the end of the word and there's nothing left. So we got an opening brace in our stack, but we have no more string left. Well, in this case, we just exit and say this does not match. So you can kind of see our different cases now. So one thing you can actually do is, instead of a stack, I'm just going to have an integer count. So we're going to have basically like int brackets, int parens, int braces. And it's going to be like this. This one is going to be parens. There we go. This one is going to be brackets. And this one is going to be braces. Kind of like this. And we're only going to track open braces because of kind of like how the flow works. So I'm going to go back into matcher here. We have basically int parens. Or actually, let's let this one go. We're going to have var parens int new var brackets int and var braces int. So my editor likes to change things around a little bit because I like the init function a lot. So you got these three values here. So this equals 0. Actually, I think you can just do this in one run. So you can go. You can also write it like this. We can do parens, comma, brackets, comma, braces, all equals 0, like this. And then because I've used colon equals, that means it's a local scoped value. But everything we're going to be dealing with is in a lower level scope. So now what we can do is basically, okay, if the character is an open brace, then what we're going to do is we're going to be, or an open paren. So parens equals parens plus 1. And it's going to be exactly the same for the other ones. This would be brackets brackets plus 1, and the last one is braces. Braces plus 1. So this is basically as we're incrementing our stack 1, we find an open one, we increment up. So then what happens when we find a closing one? So basically if we find a closing one, we want to know if parens has anything in it. So that's the first thing we're going to check. So if parens is greater than 0, we're going to do parens equals parens minus 1. So we're just going to subtract 1 because we're matching this closing paren. Okay, so good. Else, we are going to do an else here because if we had a closing one, if we had a closing paren, but there's no opening paren to match it to the left, that means we just know our string is not balanced already because we're always going to have this closing paren that's not balanced because it can't be closed by something to the right of it in the string. So then we're actually going to return false. And then, so this kind of flow is going to be the same for all of these. So let's do a little copy pasting. Convert this one to brackets. Convert this one to braces. Cool. So now we've got this done. We're returning false early if we find an unbalanced closing bracket. So what we're not doing is how do we calculate if we have too many opening brackets or if we're totally balanced. Well, we're going to do that in our return statement. So what we're going to return is basically return parens equals brackets equals braces equals 0. So this is basically the logic statement we're going to return, which is saying that basically all these should be equal to 0. If they're not all equal to 0, then we have a problem and our code is invalid. I'm not sure if this actual logic is valid in Go, but it looks like it is because my editor isn't complaining. So let's just run it real quick. 3 variables but 1 values. So I think that's actually this. That was line 7, right? 727, yeah. Alright. Okay, yeah, so I can't do that. So, how am I going to do this? So these are all integers. Why is this complaining? I wonder if I can do... Well, there's a long-winded way to do this, which is just as good, so we'll do it that way. So we basically say result equals like this, parens equals 0. Yeah. So then what we should be able to do is result equals brackets equals result equals 0. I don't actually know if that's valid or not. No, what I don't get is why exactly my types are mismatched here. So these are all integers. And I'm doing integer equality. I guess it's because this is a boolean here. Yeah, that's actually why. But what I should be able to do is this result and brackets equals 0. That should be valid. And save us. So this is brackets. So what's this and do? Basically, this is a boolean expression, and this is a boolean. So we're just anding them. So why am I anding them? Basically because this will only be true if both of these are true. So it kind of just keeps the value flowing through. So if we run this, now we're exiting cleanly. So now it's time to run our test suite. So let's see how we did. Alright, so we're passing everything. Let's do this. Alright. So we passed my entire test suite, which admittedly was only these 4 cases. But the flip side is we can probably submit our problem to LeetCode and see how it does there. So what I'm going to do is I'm just going to, so they're calling their string S. So I'm going to go in here, find all the input references, find all, place them of S, exit. All right. So now I've got my whole function here. And we should just be able to paste it in. Do a quick look around, creating these guys. Yeah. Cool. So I'm just gonna hit run code, which will check to see if it compiles. So I think I complained about this a lot in my last video, but LeetCode has some kind of weird thing running that slows down typing a shitload. I don't know what it is. Maybe it's just on Safari, but it's kind of annoying. Alright, so I passed the test case. I'm just going to check what happened to return. Oh, I just didn't copy it. Alright. We'll submit our solution now. See what this does. Interesting. So, and the way I set it up, I don't care about the order because different ones can close each other. But let's see what we got. Why is that complaining? Okay, so brackets have to be closed in the correct order. So I didn't actually make that a requirement for my program. So you might actually have to use a stack-based solution for this. But it's a slightly different problem, I guess, as I construed it. So the one I was doing in the interview was the one where it's not in order, but this one is where it is in order. So what does this do to your program is you kind of have to have a stack then. You can't just use the integer shortcut. You have to use some kind of stack and then pop things off in the correct order. I would not recommend using Go for this particular example, or for this particular LeetCode problem, because Go does not have stacks, which means you'll have to write some kind of stack structure on top of basically on top of an array in Go. Alright. So we failed LeetCode mainly because it was a slightly different problem, but all my test cases passed, so I'm pretty happy with that. I think you can do dash verbose maybe? Does that do anything? Nope. Looks like I just used the flag wrong. I'm trying to see if it will give me info on the different test cases, but it won't. Alright. So that's one version of the matching parenthesis and parens question. There's another one on LeetCode you can try that you won't be able to answer it quite the same way as I did it, but it's still going to be pretty similar. So that's going to be all for today. Thanks for watching. Let's find my little